record. Okay, we are now recording. And share the screen. Okay, quickly. So you should have gotten your score back from the exam. I emailed you back. Okay, the grading scale is 90, 80, 70, 60. So 90 is an A, 80 is a B, 70 is a C, 60 is a D, less than 60 is failing. You get to drop one exam. Okay, and remember, you have to turn in the homework. So some of you, if you submitted an exam, but you didn't turn in any homework, I didn't grade your test, like I said, you get a 0 unless you turn in the homework also. Okay, and again, that helps me prevent cheating. All right, so we are here. Now, frankly, the rest of the semester is pretty much mini calculus. You're learning very basics of what calculus is all about. It's not a full course on calculus. That's where either Math 100 series or Math 110 series for formal calculus. We're just learning a little bit of calculus, especially when it comes to business and economics. Okay, so again, the tentative schedule is I've already moved everything up one day. So that means we're here, right? 9.1, 9.2, just kind of move everything up a day. Okay, and if everything goes according to plan, okay, moving everything up a day would mean the next exam would be on Thursday, March the 25th. I think that's a perfect time for the test also, because that's just before the spring break. Otherwise, on the original schedule, you'd have to take the exam after we come back from the break. And I know a lot of you don't really want to do that. So I've sort of made up the day. So let's plan that for now, that everything is moved up a day. Okay, so we're on to 9.1. And this is the assignment 1 to 28 odd from my book, so-called. Okay, so let me go ahead and show you what I need to from there. Okay, so 9.1. Okay, the key concept is something called limits. This is brand new unless you've had calculus before. Okay, it's sort of the mathematics of closeness. You're close to a value, but not actually at a value. Okay, so you're going to start building your next formula sheet. And by the way, the next chapter is the biggest. Okay, so the first exam we had, what, 4 sections? This one we had 5. This one goes 9.1, 2, 3, 4, 5, 6, 7. There's 8 sections, but actually not doing 9.8. So that's our biggest chapter. Okay, so we won't have a test for a while. We'll have quizzes, and I plan to give you a quiz on Thursday also. And then let's see, the test after that has what, 1, 2, 3, 4, 5, 6 sections, and after that only 4 sections. Okay, well, and another quick note, a week from today, Tuesday, March the 2nd is a flex day. No City College classes on that day. So you get a break. I don't get a break, but you get a break. Okay, so after we meet on Thursday, we don't meet again until the following Thursday, March the 4th. Okay. All right, on page 536, definition of limit. I'll hold it up here. Limit, L-I-M, lim, and then see that X arrow C. We say X approaches C of f of X equals L. Okay, so what's this weird lim stuff? Lim stands for limit. X arrow C means X approaches C of f of X equals L. That means X gets very close to C, but does not equal C. Okay, it's not the value of C, but you're very, very close to C. Okay, then the function values get close to L. Okay, and of course it doesn't make sense until I show you some examples of that. Okay, and then on page 537, you have something called one-sided limits. One-sided limits. So it's almost the same thing, but now they give you a plus or minus symbol. Okay, limit from the right, limit as X approaches C, and see there's a little plus symbol next to it, almost like a superscript, like a power. X approaches C, that means you're only coming from the right. Okay, we read the limit as X approaches C, only coming from the right side. So the plus means coming from the right. It doesn't necessarily mean a positive quantity, although it could be. Okay, it means coming from the right. And then the limit from the left, they superscript with a little minus sign. So see, limit X approaches C, they put a little minus sign there. Can't really quite point it out to you, but you see there's a plus there and a minus there. See if I can kind of hold it up more for you. It's hard to focus it. But limit from the left, limit as X approaches C from the left of f of X equals M, means you're only coming from the left side. Okay, so I will show you my version of it. So this is pretty much identical. So you have it. Okay, limit as x approaches c of f of x equals L. Okay, you say, I have no idea what you're talking about. That's okay. Hopefully it'll become clear when I show you some examples. So x approaches c. Okay, so you're talking about what happens when x gets very close to c. You don't actually reach c, but you're close to c. Okay, and then f of x, which is the same thing as y, is close to L, or it's allowed to equal L in this particular case. Okay, this is sometimes called a two-sided limit. If you don't see a superscript here, something written above, it's two-sided. Okay, when you see the plus or minus symbol, they're called one-sided limits. Okay, so limit x approaches c, the plus sign means the limit from the right. You're only coming from the right side. That's a one-sided limit. The minus sign, limit as x approaches c with a minus sign, you're approaching from the left. And the minus does not necessarily mean a negative number. It could be a negative. It just means you're coming from the left. Okay, so you're either going to come from the left side or the right side. And I realize if you've never seen this before, you'd say this is all totally gibberish. I have no idea what you're talking about until I show you some examples, okay? Of which I'm going to do right now to kind of show you what it's all about. Okay, so again, the assignment was 1 through 28, the odds in my book. So I'll show you a lot of evens from what I have here, okay? I'll start that presently. Let me check the chat. If it's just for attendance, yeah, I'll get you for attendance later. Okay, attendance, yeah, okay. So if you just came late, go ahead and put your name in the chat so I can get you for attendance a little bit later. Okay, so what's happening now for the homework? So 9.1, page 545 in my book. Again, my book is the 11th edition. Show that to you, 11th edition. Yeah. Okay, so they give you all these pictures. So my book, page 545. Okay, so if you never want to get the book, you just go off of mine. So problems 1, 2, 3, 4, 5, 6. I'll do the evens. They should be just like the odds. And 7, 8, 9, and 10. Okay, so there's pictures there. And then the next page, let's see, we had to go up to 28. Okay, so 11, 12. So they give us a table there. And 13 and 14. And then 15 through 28. Let me see. I'd have to refocus this a little bit. Try to raise it up there. 15, 17, 18, 19, 20. Sorry if it's not focused. It's hard to do that and carry the book because the book's heavy, as you know. And we have to go up to 28. So I think you can see it all now. All right, so there's 3 different kinds of problems. 1 through 10 are based on pictures. 11 through 14, you're plugging into a calculator. And then 15 through 28, they just give you some expression. Okay. So here we go. And again, unfortunately, this is a situation where I'm not going to be able to write stuff down because I have to hold the book up. So sorry about that. You either write it down as I talk about it or look at the video a little bit later. Okay, so 1 and 2 are very similar. So I'll do 2, you do 1, I do 4, you do 3, I'll do 6, you do 5, and so on. Okay, so number 2, they give you a value of C. For each problem, use the graph to determine the following. Okay, part A, the limit as x approaches C of f of x. So we are getting very close to the value of C, but not at C. Then part B, f of C. F of C, you're right at that value. Not a little bit to the left, not a little bit to the right. You're exactly at that value. Okay, so number 2, C equals 6. Okay, so here's 6, 3, 6, 9. Okay, when I get very close to 6 on both the left side and the right side, so here I'm coming on the left side, here I'm coming on the right side, the y values are up around 6 also. Okay, so the answer to 2A is 6. Sorry, I'm not going to be able to write it, but just jot down in your notes, maybe 2A is 6. Okay, when I get very close to 6 on both the left and the right side, okay, the y values are near 6. B, f of c. That means you're not a little bit to the left, you're not a little bit to the right, you're exactly at 6. Is there a dot? Yes, there is, and that's also 6. Okay, so again, the answer to 2B is also 6. Okay, so quickly again, the answer to 2A is 6. The answer to 2B is 6. Okay, it's not really that interesting. It gets more interesting when I look over here at the other ones. Okay, so let's look at number 4. C equals -10. Okay, now take a look. They give you an open circle at -10, 15. Okay, see that open circle there? You can't quite, but I can hold the book temporarily. Open circle, right? All right, so part A, limit as x approaches C, which is -10. Okay, when I get very close to -10 on both the left side and the right side, the y values are near 15. Okay, so the answer to 4A is 15. Okay, so if I move just a little bit to the left or a little bit to the right of -10, the y values are near 15. However, part B, it asks for f of C, right smack dab at -10. Not a little bit to the left, not a little bit to the right. What's the function value right at -10? There is no function value. Okay, there's an open circle here. Okay, so we will say does not exist. Okay, so our abbreviation that we'll use quite a bit is DNE for does not exist. Okay, so DNE for does not exist. Okay, DNE does not exist. So the answer to 4B is DNE does not exist. Okay, 6. Let me adjust this a little bit. 6. C equals -2. Okay, so part A again. Part A, limit as x approaches C of f of x, where the C is -2. Okay, so when I get real close to -2, either on the left side or the right side, the y values are near here, which is 0. Okay, I come this way or this way, y values are near 0. So then the answer to 6A is 0. How about part B? F of C, f of -2. There is a dot, but it's not here. It's way up here. It's at 2. Okay, so the answer to 6B is 2. Okay, so there we go. All right, so I did the evens, you do the odds. They're very similar. Okay, I'm willing to rehash very quickly. Okay, so back again, 2A is 6. 2B is also 6. I don't know why it's yellow now. 4A is 15. 4B does not exist, DNE. 6A is 0. 6B is 2. And I got to put the book down because it's heavy. Okay, and let me check the chat. Let's see. Okay, some more people just joined. Okay, got you. I'll get that a little bit later. Okay, are we supposed to answer if the limit exists? Just give the number. So if the limit is 7 or 4, that tells you the limit exists. If the limit doesn't exist, then just put DNE. Okay. Okay, 7, 8, 9, and 10. There are now one-sided limits going on here, possibly. Okay, so look at A. A, limit as x approaches C, and there's a little minus sign there. Okay, for A. That means you're only coming from the left side. B, limit x approaches c, and there's a plus sign, means you're only coming from the right side. And then part C is a two-sided limit. Limit as x approaches c of f of x. That means you have to get the same value for a and b. If you don't get the same value for a and b, then the answer would be does not exist. And then part D is f of c, the function value right at that point. Okay, so again, 7 and 8 are similar. I'll do 8, you do 7. And 9 and 10 are similar. I'll do 10, you do 9. And of course, those of you that have the book, the answers are in the back of the book. Okay, 8, c equals 2. Okay, so I can't quite do this. So here is 2. So I approach the function from the left side. If I approach the function from the left side, the y values are shooting up to infinity. Okay, so 8a is infinity, the sideways 8. Part B, x approaches c. Oh, I'm sorry. No, I had it right. Yeah, it's left first and then right. B, see how there's a plus sign? So we're approaching 2, excuse me, we're approaching 2 from the right side. So when I approach 2 from the right side, we drop to negative infinity. Okay, so 8b is negative infinity. 8c, two-sided. So if it's two-sided, you have to get the same answer from the left as from the right. In other words, 8a and 8b have to be the same. They were not the same, right? One was infinity, the other was negative infinity. So 8c does not exist. And you can abbreviate D and E. 8c does not exist. And then 8d, f of c, right at 2. Not a little bit to the left, not a little bit to the right. Is there a dot anywhere at x equals 2? I don't see any. Okay, so 8d is also does not exist. D and E. Okay, so recap again. 8a should be infinity, coming from the left. 8b is negative infinity. 8c does not exist. And 8d does not exist. And you can abbreviate does not exist, D and E. Okay. And let me check the chat. Okay, caught up. All right. Yeah, anybody who joined late, just go ahead and put your name in the chat and I'll get your attendance later, since I already put it away. Once I put it away, I don't have to take it back out. Okay. All right, the last of this type is 10. C equals 2. Same thing. Okay, so A, limit from the left. B, limit from the right. How do you know? There's a minus or a plus. Put this on your next cheat sheet, if you wish, your next formula sheet. And C is two-sided. How do I know if it's two-sided? Because there's no minus or plus there. Then it asks for f of C. Okay, so let's take a look for number 10. As I approach 2 from the left side, coming this way, the y values are down here. So where's here? Negative 2. Okay, so 10a is negative 2. 10b, we're coming only from the right side. So I approach x equals 2 from the right side, I'm over here. So where's here? 0. Okay, so 10b is 0. And then 10c, okay, look at 10a, there's a minus sign next to the c. 10b, there's a plus sign next to it. And the third one, C, there's no symbol next to the C, so that's two-sided. So did I get the same answer for part A and part B? No, I did not. From the left, I was down at negative 2. From the right, at 0 for Y. Okay, so 10C does not exist, D and E. And then 10D, F of C, right at x equals 2. Is there a dot? Yes, there is. Right over here, and that's 0. So 10D is 0. Okay, so quick recap again for question 10. 10A is negative 2. 10B is 0. We get your y value. 10C does not exist, D and E. and 10D is also 0. Okay, and that's it. And check the chat. Yeah, okay. So I got people. All right. Okay, so if you want to know how to do the ones that are assigned to you, 1, 3, 5, 7, 9, look at how we did 2, 4, 6, 8, 10. They're almost identical, completely identical. Okay, again, like I said, it doesn't really matter which version of the text you use, as long as you see these problems in your book, then go ahead with it. Okay, the next type are 11, 12, 13, and 14. For you, it's really only 11 and 13. So I did number 12 for you. And again, I pre-did all of these. So I don't want to waste class time on what the values are. And you don't want to watch me punch this in the calculator. I'm just going to go with it. Okay, so you do 11 and 13. I'll do 12. Okay, f of x equals 2x plus 1 over 1/4 minus x squared. They want the limit as x approaches negative 0.5 of f of x. Okay, and you get a table here. Okay, what's going on is, okay, negative 0.5, right? Negative 0.51, negative 0.501, negative 0.5001. These are values that are getting very close to negative 0.5 coming from the left side. These numbers are a little bit smaller than negative 0.5. Okay, so the top three. Okay, these are approaching negative 0.5 from the left. These three are approaching from the right. Okay, negative 0.49, negative 0.499, negative 0.4999. I'm getting very close to negative 0.5 coming from the right side. Okay, and here's the interesting thing also. If you actually plug in negative 0.5, you're gonna get a 0 in the bottom. You'll be dividing by 0, and that's not allowed. That's a mathematical no-no. Okay, but that's not what this says. Okay, this does not say you're really plugging in negative 0.5. You're plugging a number very close to negative 0.5. Okay, you can check it. If you plug in negative 0.5, if you square it, it's equal to 1/4. 1/4 minus 1/4 is 0. Can't do it. So f of negative 0.5 is not defined. However, the limit may exist. Okay, so I plug these in. I'm not going to waste class time to do that, but I've done it before. Plug all these in, plug all these in. Do they seem to approach any number? Okay, you do the same thing for 11. See what's happening over here. Limit as x approaches 1. You can tell you're not allowed to plug in 1, right? But you can plug in numbers that are close to 1. 0.9, 0.99, 0.999. That's getting close to 1 coming from the left. 1.1, 1.01, 1.001. That's getting very close to 1 coming from the right side. Okay. And same thing for 13. I guess they have 1 again. Right? So you do the same thing for 13. 0.9, 0.99, 0.999. Difference is that for these three numbers, you have to use the top function because it says x is less than 1. Right? Then here, 1.1, 1.01, 1.001, you have to use the bottom function because x is greater than or equal to 1 in this case. Okay, so let me show you the table for 12, and that will pretty much do it, hopefully. All right. So here's problem 12. Maybe you can't really see it. Problem 12. Okay, so these are the ones right off the text. Negative 0.51, negative 0.501, negative 0.5001, coming from the left, coming from the right, negative 0.49, negative 0.499, negative 0.4999, and so on. Okay, so I took all of these numbers and plugged them in there and there. Then I took that one, plugged it in there and there. All 6 of them, okay, plug it in. Okay, it wastes too much class time to do it, so I pre-did it. And here's what you get. Coming from the left side, 1.98, 1.998, 1.9998. The top 3 going this way. And then going from the right side, 2.02, 2.002, 2.0002. Okay, so you can see if I go this direction, whoops, coming from the left, or this direction coming from the right, does it look like we're approaching any one number? It does, right? I mean, look at 1.98998, 1.9998, 2.02, 2.002, 2.002, okay? Coming from both the left and the right sides, we're getting very close to 2. So that's what we're going to say. Limit as x approaches negative 0.5 of f of x is equal to 2. Even though f of negative 0.5 is not defined, I cannot plug in negative 0.5. But that's what's happening here. This symbolism says we're plugging in numbers very close to negative 0.5. And if I plug in numbers very close to negative 0.5, then the numbers are very close to 2. So the limit exists, even though the function value right exactly at 2 does not exist. Okay? So that's what's happening there. Right, so the answer is 2. Right, so that's how you do 11, 12, 13, and 14. Okay, and then the last batch, 15 through 28. Okay, you have some very easy ones. 15 through 18 are fairly easy. You just plug them in. It's basically algebra 1. Okay, and then it gets harder starting with 19. Okay, so starting with 19, you have to do some algebra trick. Okay, so again, I'll go down to evens. So I'll show you 16. It's very much like 15. I'll do 18. It's very much like 17. And right, so 20, 22, 24, 26, and so on. And you do, 19, 21, and so forth. Okay, or whatever the equivalent in your book. Okay, so 16, please. Limit as x approaches negative 35 of 34 plus x. Okay, now the easy ones are if you can just plug in. So the rule is if you can plug in, do so. You say, what do you mean by that? When I plug it in, just put negative 35 there. 34 plus negative 35, the answer is 1. Done. What can be easier, right? In other words, if you can plug in, do so. That's really too easy. That's just like algebra 1, just plug in negative 35. That's too easy. So they don't give us too many problems like that. Okay, the rest are harder. You have to do some algebra trick. Okay, here's 18. Limit as x approaches negative 1 or 4x cubed minus 2x squared plus 2. Okay, just plug it in. 4 times negative 1 cubed minus 2 times negative 1 squared plus 2. Okay, negative 1 cubed, negative 1 times negative 1 times negative 1 is negative 1. Multiply that by 4, you get negative 4. And then negative 2 times 1. Negative 2 times 1 is negative 2 plus 2. So my answer is negative 4. Okay, so frankly, these are too easy, in my opinion. Just plug it in. Okay, although technically this is not what it's saying. Okay, this symbolism does not mean when you plug in negative 1, you get negative 4, although that's true. It means if you plug in a number that's very, very close to negative 1, negative 0.99, negative 1.01, the answer will be very close to negative 4. We're sort of doing mathematics of closeness now, right? And frankly, you've all done this before with estimation, right? Like, do a quick timeout. Okay, this is not something from the book, but you've all done estimations like this before, I think. Oh, I don't know. No calculator. Give me an estimate. You would say 8 times 7, 56, right? Right? I don't need a calculator for that. Say, well, that's a number that's very close to 8. That's a number that's very close to 7. So if I multiply it, I get an answer that's very close to 56, right? Now you can punch it in your calculator, but I don't think you have to. You know it's going to be, 56.001 or 55.99 or whatever, right? That's exactly what's happening here. We're estimating. Okay, so yes, even though when you plug in -35 here, you get -1, but that's not what this is really saying. It's saying if you plug in a number very close to -35, your answer is going to be very close to -1. Just like all of you should be able to say, okay, I don't know what this is, but it's going to be about 56. Because you just look at this and say, okay, 8 times 7, right? And then if you punch it out, you'll see it's probably a little bit smaller, a little bit bigger. Okay, and something similar for 20. Limit as x approaches -1/2, 4x minus 2 over 4x squared plus 1. Okay, so if you can plug in, do so. So I just plugged it in. Put -1/2 right there, -1/2 right there. 4 times -1/2 minus 2 divided by 4 times -1/2 squared plus 1. Clean it up. So 4 times -1/2 is -2. -2 minus 2. What is -1/2 squared? -1/2 times -1/2 is positive 1/4. Okay, clean this up. What's 4 times 1/4? 1. So the bottom is 1 plus 1, 2. The top is -2 minus 2, -4. -4 divided by 2 is -2. Okay. All right, so I declare 16, 18, and 20 as quote unquote easier problems. All you got to do is plug in. Okay. So if I gave you something like this on the quiz on Thursday, you should say this is a piece of cake, just plug it in. Okay, so now for the harder ones where you cannot just plug in. Okay, so starting with 22, I believe, is like that. Okay. Look at 22. X approaches -4. I can't plug in -4 to the bottom. You're dividing by 0. Same thing with 24. Same thing with 26. Okay, let's take a look at why. So 22. Limit as x approaches 3 of x squared minus 9 divided by x minus 3. You cannot plug in. So why don't I just do it like all the other ones? If I plug in 3, you're dividing by 0. You're never allowed to divide by 0 in mathematics, right? That's a mathematical no-no. So the trick this time is to do a little bit of algebra. I will declare that even though f of 3 does not exist, right? You cannot plug in 3. But in reality, you're plugging a number very close to 3, like 2.9, 2.99, 2.999. That's allowed. Or 3.1, 3.01, 3.001. That's allowed. Okay, now the slow way is to make a table like this. The fast way is to do a little bit of algebra. Okay, x squared minus 9 is the difference of 2 squares, you might recall, right? So maybe from your algebra, you recall, oh yeah, x squared minus 9 factors into x plus 3, x minus 3. And then you say, oh, there it is. I can cancel x minus 3 with x minus 3. So I have limit as x approaches 3 of x plus 3. Now you can plug in directly because I'm no longer dividing by 0. Is that right? So now I just plug in 3, 3 plus 3, 6. So my answer is 6. Okay, so the harder problems, if I were to give you something like this, you do a little bit of algebra first. You don't plug in directly right away, right? Okay. In fact, they give you more problems like this than this because these are frankly too easy. You just plug it in and you get it. Okay. But for the harder ones, there's trouble usually because you're dividing by 0. So you have to do some algebra trick to simplify it, so to speak. Okay, so one more time, you can't plug in 3, but if you factor the top, x squared minus 9 is x plus 3, x minus 3. Okay, and then you say, oh, cancel this out. So I have limit as x approaches 3 of x plus 3. Now you plug in 3 plus 3 is 6. Okay. And that's the basic idea behind all the others of these, sort of. Okay. So 24. Limit as x approaches 7. X squared minus 8x plus 7 over x squared minus 6 minus 7. Okay. So again, you cannot plug in 7 directly. Why not? So 7 squared is 49. Minus 6 times 7 is 42. So it's 49 minus 42, which is 7. 7 minus 7 is 0. So again, you're dividing by 0. Can't do it. So instead, do some algebra. So factor the top, factor the bottom. Okay, so you have to think back to your factoring from algebra. And that's the reason why we had a factoring review at the beginning of our course even, right? Chapter 0, 1, 2, and 5, review of algebra. So x squared minus 8x plus 7. What two numbers have a product of 7 and a sum of 8? That would be 1 and 7. And a minus and a plus means they're both minuses. How can you check your answer? Multiply it back out, right? X squared minus 7x minus 1x is minus 8x. And then negative 1 times negative 7 is a positive 7. And the bottom, you have a negative here, which means the signs are opposite. One's a plus and one's a minus. So this time I want numbers with a difference of 6 and a product of 7. That's still 7 and 1. Only difference this time is that you want a minus with a 7 and a plus with the 1, because you want to end up with a negative. Again, double check with FOIL. FOIL that back out. X squared minus 7x plus 1x. So I got to put this down so it's a little bit out of focus. But x squared minus 7x plus 1x is a minus 6x, and then minus 7. Whoops. Paper's running away. And there it is. Now you cancel these out. So after you cancel these out, right, you have x minus 1 over x plus 1, limit as x approaches 7. Now you can plug in. And by the way, this is the proper way you're supposed to write this mathematically. Okay, so I can't take off points for this if you don't write mathematics properly. You're supposed to keep writing limit x approaches 7, limit x approaches 7, until you finally plug in. Until you plug in your answer, keep writing the limit x approaches 7. Now that I plug in, you don't have to write limit anymore. So 7 minus 1 over 7 plus 1, 6 over 8, 3/4. Okay, so your final answer should not have the lim stuff. Okay, but you keep writing it as long as you don't substitute it in yet. Okay, so that's the basic idea behind these. Okay, 26 and 28. I got 26 over here. Okay, that one's a little bit more unusual, unfortunately. So limit as x approaches a half of 8x squared minus 4x divided by x minus a half. This one's a little bit strange. You know you can't plug in 1/2, but I will declare the limit still exists because I'm not plugging in 0.5 really. I'm plugging in 0.4999 or 0.50001, and that will exist. Okay, so here's what I did. First thing I did was factor the top. So what's the greatest common factor? 4x. So 4x, 2x minus 1, ignore the red temporarily. So 4x times 2x minus 1 is the same as the top. Double check. What's 4x times 2x? 8x squared. What's 4x times negative 1? Negative 4x. Okay. I don't like that half, right? A way you can get rid of that is to multiply the numerator and the denominator by 2. Okay, so multiply by 2 over 2. That's fair. Okay, and I'm going to take that 2 and multiply it by the 4x. I'm allowed to do that. I'm going to leave this one alone, and there's a reason for that. So 4x times 2 is 8x. Look at what happens if I multiply out the bottom. 2 times x, 2x. Negative half times 2, negative 1. So that was kind of tricky. There's the 2x minus 1 that I want. And then I can finally cancel these out. So then I have limit as x approaches a half of 8x. Then I can just plug in 8 times 1/2. My answer is 4. Okay. So again, even though you're not allowed to plug in 1/2, you'll be divided by 0. I can plug in numbers that are very close to 1/2, And if I do that, my answer should be close to 4. Okay. So you can make a table like this. I'm not sure if I want to do that now, but I'm almost done. We got plenty of time. It's only 5:25. Okay, do I feel like doing this? Maybe I will. So that means if I plug in a number like 0.49999 to all this junk here, I should get a number that's close to 4. Okay, so let me go ahead and try it just for fun and see if it works. Okay, so 8 times how about 0.499 squared minus 4 times 0.499 divided by parentheses 0.499 minus a half, which is the same as 0.5. Okay, so I plugged in here, here, and here, 0.499. 3.992. It works. I got a number that's very close to 4. So that kind of verifies that. And likewise, if I pick a number slightly bigger, like 0.501, I should also get that. If I want to do that, okay, I'll do it. A number a little bit bigger is 0.501. So 501 minus 4 times 0.501 divided by 0.501 minus 5. So I plugged in 0.501. 4.008. Yes, indeed. Right? So I came from the left side and the right side. The limit does exist. It's 4. Even though right at 1/2, exactly at 1/2, the limit does not exist. I'm sorry, the function doesn't exist. F of 1/2 doesn't exist. Okay. So you could make a table here, but obviously we don't want to do that too much because that's very tedious to do this. Okay, then 28, and then I'm done, folks. It's not even 5:30. I'll be done in a few minutes, in which case I'll let you ask any questions, and if there are no questions, we can just call it a day. Okay. And so a reminder on our schedule, our calendar, we're moving everything up by a day, sort of, right? 4. Right, so your calendar should now be 9.1, 9.2, 3, 4, 5, right? And that means on the back side, the next exam is Thursday, March the 25th, just before spring break. And if I gain that date, then I land exactly. So that means exam 5 tentatively is May 13th. I mean, that's quite a while in the future still. Then we can have 1 day for review, and the final exam is on the 20th. Okay. Well, yeah, so I prepare for a quiz, but you know, the quizzes are all low pressure. You get to talk about it and help each other out. So I'll ask you one of these limits. Okay. So the most likely scenario is I'll pick one that's easy where you just plug it in, and I'll give you a harder one where you have to do some algebra to get it to work the right way. Okay, for Thursday's quiz. So that means on Thursday, I'll get started with what, 9.2? Okay, so I'll do 9.2, do all this stuff, and then after a certain while, I'll stop and give you the quiz, which would be one of these limit things. All right, 28. Limit as x approaches -6 of 2x squared minus 72 over 3x squared plus 18x. All right, so we will factor first. On top, I can take out a 2, right? 2 times x squared minus 36. Bottom, I can take out a common factor of 3x. So 3x. And then what's left behind is x plus 6. You can always double check by multiplying it back out, right? 2 times that, 2x squared minus 72. 3x times x is 3x squared. 3x times 6 is 18x. It works. And by the way, you can tell right now, you cannot plug in -6, right? Because if you plug in -6, that's 0. But let's keep factoring. X squared minus 36 is also difference of 2 squares. So 2x plus 6, x minus 6 over 3x, x plus 6. And that's what we want. That's usually what happens in this kind of game here. So x plus 6 cancels out. Notice you keep writing lim, 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 lim until you're ready to plug in. That's proper. So if you don't write it, I can mark it as partially wrong. You get partial credit, but you're supposed to keep writing it. So if that cancels that, I now have limit x approaches -6, 2 times x minus 6 on top and 3x on the bottom. And now you can plug in no problem. Okay, so now I'll plug in -6 right there, -6 right there. So 2 times -6 minus 6 over 3 times -6. Got a lot of negatives here. So 2 times -12 divided by -18. 2 times -12 is -24. So I have -24 over -18. Negative divided by negative is positive. And looks like you can factor out a 6, right? So divide top and bottom by 6. So final answer is 4/3. And there we go. Okay, so that pretty much does it. So again, and that would be typical for all the lectures from here on out. I'll show you how to do the evens. Okay, so if I show you all the evens, the odds are just like it. You go back and do the odds that are quote unquote like it. All right, let me check the chat. Okay, okay, that's fine. Right, yeah. If you ever join late because of connection problems or you got disconnected, I get it. You know, look at the video later. I got disconnected several times. So, you know, if it happens, it happens, and we'll just go from there. All right, so I think we're done, folks. So beware. I'll give you a quiz next time, and it'll be most likely something like this. One easy where you pretty much just plug in, and a harder one where you have to do some algebra first, and you can't plug in because you're dividing by 0. So that'll be the second half of the next class. Next class is going to be on 9.2, right? Okay, any other questions? Let me see. Check the chat. The quiz will cover 9.1 and 9.2. No, just 9.1 and just on limits. Okay. So I'll give you something quote unquote easy and hard. So how about one question would be something like 16, 18, and 20. Easier. Basically, you plug in. And the harder question, you got to do a little bit of algebra. You can't plug in right away. So you have to do some algebra and then maybe cancel and go from there. Okay. I mean, you have to admit the quizzes I'm giving you are very low pressure, I think. You can use your book, you can use your notes, you can help each other out, right? Talk to your teammates about it. So it shouldn't be any big deal, I think. Okay, any other questions, please? You can unmute yourself and put it in the chat. Otherwise, we're done, folks. Okay, I see nothing and hear nothing, so that means we're done. All right, folks, so we'll see you on Thursday. Next time, we'll go to the next section. All right, okay, have a good evening, everyone. Bye, see you next time. Okay, good night, everyone.
Thank you.
Thank you. Good night.
Thank you.
Hi, Professor. I have a quick question. I don't know if I should schedule an appointment with you offline or if I could stay now, but I just wanted to get an idea of like where I'm currently standing in the class because we don't post grades on Canvas. I was just curious to know if there's anything.
Yeah, Rose, send me an email. That's probably the best way to do it because, yeah, I don't use Canvas except to just give Canvas announcements.
Okay, Professor. I'll send you an email. Thank you.
Yeah, send me an email. Okay. Thank you.